Okay, so for the first question is it asks for available probability mass function. So we can see that k is a discrete random variable, and we know that the sum of px equals to k from k equals to 0 to infinity should equals to 1. So we can write this part out like, first of all, we know that p to the power of k is equals to 1 over 1 minus p, and we can take derivative of both sides, and we get k times p to the power of k minus 1 equals to 1 over 1 minus p to the power of 2. So this we can relate this part to this part. So since we know that the sum of k equals to 0 to infinity of b times k times p to the power of k minus 1 should be 1, so then we plug in this part and make it equals to 1 over 1 minus p to the power of 2, then we get b equals to, only when b equals to 1 minus p to the power of 2, this equation can equals to 1. So we find the valid b that can make this a valid probability mass function. And so for part B, it asks for the expected value of x. So we know that the expected value of x is k times b. It's like k times the PMF for k equals to 0 to infinity. So it's this equation, and we want it is more like a math problem. So my idea is to take derivative just like the first part. Like we know that from the first part that k times p to the power of k minus 1 equals to 1 over 1 minus p to the power of 2, then we can times p, so we get k times p to the power of k equals p over 1 minus p over 2, and then we can take derivative of both sides, and then we get k to the power of 2 times p to the power of k minus 1 equals to 1 plus p over 1 minus p to the power of 3. So then we can plug into this equation and get b times 1 plus p over 1 minus p to the power of 3 equals to we can like make this to make it simplify this and get 1 plus p over 1 minus p. And similarly for part 3, which asks for x expected value of x squared. So it's built on part B, which we again times one more k. So it's k squared times bkp to the power of k minus 1 instead of only 1k. So it's similar, but from part B we get k to the power of 2 times p to the k minus power of k minus 1 equals to this, and we can again times p to this side, and so to eliminate the minus 1 part, and then take derivative. So we get again k to the power of 3 times p to the power of k minus 1 equals to this. Yeah. So, and then we plug in this equation here and knows that b times this should be the answer. And this is the answer. And so for part D, it asks for expected value of x squared minus expected value of x to the power of 2. So it's like based on the part B and part C. So from part B we get what is the expected value of x, and part C we get the expected value of x squared. So we just use the answer from part C to minus the answer of part 2 in the power of 2, and get 2p over 1 minus p to the power of 2. And it should be clear that expected value of x squared is different from the expected value of x to the power of 2. And for part E, let p equals to 1 over 3, find the conditional probability mass function. So we first plug in 1 over 3, and we know that the b equals to 4 over 9. And then we use the rule from first class, like given x greater than 2 less than 5, the probability of x equals to k should be equals to x equals to k and x greater than 2 and smaller than 5 over the probability of x equals to k. And we know from the equation that this can also change to the probability. We can know from this equation and plug in the numbers. So from 2 to 5, the probability of x equals to 2 to 5 is here, and we can then get the answer of given x greater than 2, smaller than 5, x equals to k. It's this formula.